So we're going to do a brief aside here on an algebraic topic that's going to help us calculating some or finding some points in geometry. So that topic is averages. And so I think most of us are probably going to be good with just calculating a normal average. But I want to highlight some important points, and then we're going to talk about a weighted average is actually our goal. So let's just take an average of two numbers. So an average, I'm going to refer to this as an arithmetic mean. A mean is another word for average, because there's other types of means out there as well that we'll discuss later. But what they do is they find us, a middle between, two or more numbers. So, real basic example, what if I have the numbers 4 and 8? So to find the average of 4 and 8, all I do, of course, is just add them together, and then I will end up dividing by 2. So I'm taking the two numbers that I'm averaging, dividing them by how many there are. When I do this, I get 6. Okay, so 6 is the average of 4 and 8. This makes a lot of sense because if I think about this on a number line, if I think about 4 and then 6 and then 8, so the difference between 4 and 6 is 2. The difference between 6 and 8 is also 2. So I have found the number that is halfway in between them. Exactly in between. It's the average of the two. So two numbers, no big deal. But what if I have 3? So what if I have the numbers, let's say 9 and 10 and 2. So if I average these three numbers, I'm going to do everything exactly the same way. I'm going to add them together, and I'm going to divide by the number of items that I have, which in this case is 3. And when I do that, I get 19 plus 2 is 21, divided by 3 is 7. So 7 is the average between these two numbers. So maybe we should take a look at this. So if I have a number line, let's look at a number line real quick. So I have, 2 down here. I got 3, 4, 5, 6, 7, 8, 9, 10. I guess I had a little extra. 9 and 10 are all the way down here at this end. And 7 is right here. So 7 is the average between 2, 9, and 10. And what we notice here is that 7 is obviously much closer to this side of my number line as opposed to this one. Because I had two numbers down here, two larger numbers that are obviously weighting my average down. 7 is drawn much closer to 9 and 10 than it is to 2. In fact, it's only 2 units away from 9, 3 units from 10, but 5 away from 2. So let's emphasize this even maybe a little bit more. Let's just look at the numbers, something that'll work out nicely here, 10 and 10 and 1. If I do the same thing, so I'm still going to add these together, I will still get 21 up top. So my average will still be 7. And so when I think about this, again, I can look at my number line. I'm starting at 1 this time, though. 2, 3, 4, 5, 6, 7, 8, 9, and 10. And this time, 7, which is right here, is 3 units away from 10, but it is 6 units away from 1. So this is actually really interesting. I have 2 10s that I'm averaging here, and then just 1 1. I have twice as many 10s as I do 1s in this case. And so when I average them, it makes sense that my distance here between my numbers, so 7 to 10 we said is 3, and 7 to 1 is 6. That distance now is twice as close to 10 as it is to 1. And so whenever I double the numbers I have here, it makes that average twice as close. It's twice as close because there's 2 of them and only 1 of this one. It's now twice as close. So what this is leading us to is actually this new idea of what's called a weighted average. So what weighted averages are is saying, hey, I still want to average numbers together. I want to find a number that's in between, or a central tendency of the numbers. But some numbers are more important to me than others. So what I can do is, let's look at that 10 and 1 example. So let's say I want to average the numbers 10 and 1, but let's say this 10 is twice as important to me. So what I'm going to do is I'm going to take a weighted average and say I want to find a number that's twice as close to 10 as it is to 1. So the way that I'll do that is I will take the number that I care twice as much about, and I will add that to the number that I only care 1 times as much about, and I'm going to divide by how many parts I have. So before I divide by how many numbers I have, I only have 2 numbers here, but how many parts I have? Well, I've double weighted this one, so that's 2 parts, and I've single weighted this one, so I have 3 total. And so what I get here is 21 over 3, so 7, and so 7 is the number that's twice as close to 10 as it is to 1. It's 3 units away from 10, and it's 6 units away from 1. It's twice as close. Let's look at a different one. Let's look at the numbers. How about 8 and 16? Except this time, let's not double weight it. Let's go even a little bit further. Let's triple weight the 8. So I'm going to try and find a number that's 3 times as close to 8 as it is to 16 here. So I'm going to do that. I'm going to take my 8, and I'm going to multiply it by 3. I care about it 3 times as much. I'm going to add that to 16, which I only care 1 times as much about. And I'm going to divide by, well, how many parts do I have? I have 3 here, and I have 1 here. So in total, I've got 4 parts. When I add these together, this is 24 plus 16 over 4. So that's 40 divided by 4, which is 10. All right, so let's look at these real quick. So I had the number 8. I had the number 10. This is my weighted average. And I had the number 16. And so what I was really trying to do is I was trying to find a number 10 that is 3 times as close to 8 as it is to 16. So let's see if I did that. Well, if I look at the 8, I have a difference here of 2. And if I look at the 16, I have a difference here of 6. So what that means is that this number is, in fact, 3 times as close to the 8 as it is to 16. So these weighted averages are real helpful here if I don't want to find just the number that's right in the middle, but if I want to find numbers that are, a different proportion in between 2 points or two values. Let's look at another example that actually pertains to us in a little bit different way. So our grades for a semester are weighted in certain percentages. Those percentages are 40% go to our quarter 1 grade, 40% go to our quarter 2 grade, and then 20% goes to our semester final or exam grade. And so the reason we do this is because, well, at the end of the semester, we want to check to make sure you still, you learned something. But before that, the work you've done up until that point, it's just more valuable to us. You've been showing us all along that you've learned things. And so we've weighted them at 40% of your grade instead of 20%. So let's say, for example, we, go through our first quarter. We do okay. We get an 84 in the class. Our second quarter, we improve. We get an 88. But then our exam, we work really hard. We study a lot, and we get a 96% on it. So what is our final grade going to be in the class? Well, I can use a weighted average to figure it out. These are the proportions I care about these numbers in. So what I can do is I can say, let's take 84 and multiply it by 40. Let's take 88 and multiply it by 40. And let's take 96 and multiply it by 20. And what I need to divide by is how many parts I have. Well, I've got 40 parts here, 40 parts here, and 20 parts here, which makes sense because it's a percentage. I can divide by 100. And what I get is, I have to bring a calculator out for this. Let me check. What I'm going to get is my final grade for the class. So 84 times 40 plus 88 times 40 plus 96 times 20, and divide that all by 100. And what I get is actually a grade of 88 for the class. And so we can think about why this is. So you think, hey man, I did really well here. I got a 96 on my final. Shouldn't my grade be higher? But the issue is that, well, 80% of your grade are in these two chunks. And so they're going to have the greatest impact. Before you took the final, your average was an 86, but it only got brought up by 2 points because it's only 20% of your grade. So this is weighted averages. They help us find numbers that just aren't right in the middle between a pair of numbers or a set of numbers, but rather they help us find numbers that are skewed to one side or the other. So these are going to be really helpful for us later when we start talking about these in terms of points as well.